name is Bree Rodriguez, and I'm a SWES student at the University of Arizona, currently working thanks to the Summer Research Institute on compost. So I'll just jump into my methods. For this experiment, there were 6 treatment plots and 6 control plots set up right in front of the Flandreau Observatory. These plots have been undergoing this treatment since last year. And so far, we've collected pre-monsoon and post-monsoon last summer and the pre-monsoon samples from this summer. The samples we collect are chosen, these plots are 9 by 9, and each time we go in to collect our cores, we select a new spot within the 9 by 9 plot. And the cores we select are, first we take a chemistry core, which is, if you ever see any of us out there, it's this big thing and it takes a nice huge core out, and those are the samples we use for both bulk density and soil chemistry, such as total nitrogen and total carbon. The next cores that we take out are microbial, which are right next to the chemistry cores. We just take out a little 1 by 1 by 5 centimeter piece, and the sample we take for nematode analysis is exactly the same size. So for bulk density, these are my pictures. It's very simple. It's basically you get your cores, you put them in the oven, you dry them, and you divide your dry weight by the total volume of the core. This is very simplistic, but it gives you good insight as to how much pore space there is within the soil, how much sponginess the soil has. And the more sponginess, the more ability a soil has to let water percolate through and contain the water and the air for more cycling to be happening within the soil. I have not been able to do my total nitrogen and total carbon, organic carbon processing yet. I know that I will be doing this up at the biosphere using the Shimatsu analyzer. And I pretty much just I've already crushed my samples. You pulverize your soil and you put them in a little crucible, shove it into the machine, and it gives you the amount of organic carbon. And so I'm hoping to do that. These are mostly placeholders, and it's the same with the nematode counts. I know I'll be using this method that you leave the soil soaking overnight and the nematodes will swim on out. But I'm hoping to do this soon. The greenhouse gas fluxes were measured using these chambers and I'm hoping to get a picture of the actual chambers to put on here, but there are these little chambers, and you pretty much put them onto the soil on top of the grass in this instance, and with stakes that are just similar to the ones you use for your tent when you go out camping. You fix it onto the soil and you just let the gas fluxes change, and these gas fluxes are measured in situ just using infrared radiation, or absorbance of infrared radiation. And the gases we measure are nitrous oxide, CO2, methane, and water vapor. So the microbial diversity analysis, this is what I've been mostly trying to figure out over the summer, is how to use CHIME to analyze the data from last summer. As soon as the samples are collected for microbial, the first slide with the microbial diversity sample that I collect goes straight into the -80, so it's nice and safe there until I get a chance to do my DNA extractions, and then those get sent to be sequenced, and the data gets analyzed using CHIME. So results so far, the only for sure results that I have as of yet are my bulk density, and unfortunately it doesn't show anything very specifically. It doesn't point out any exact result, because as you can see, bulk density either stayed the same or pretty much was less or equal compared to last year. And yeah, my hope would have been to see all bulk density decrease, which are the minus signs, but that was not the case for all of them. I wanted to put this up just because I want to see how it looks, because it's very messy, as you guys can see. These are my results using CHIME to analyze the microbial diversity from the samples last year. I'm still messing with them in Excel. You can see control, all of the 12 on this side are control, the 12 on this side are treatment. These 6 are pre-monsoon, post-monsoon, pre-monsoon treatment, post-monsoon treatment. And what would be nice to see is some sort of pattern where you could see either phyla levels increasing or decreasing, but I haven't found any pattern quite yet. And I mostly just wanted to see what that graph would look like. I know I need to mess with it more. And then this is, again, another, yeah. And this graph is down to the genus level, but this is kind of cheating because 85% of my samples were not identified all the way to the genus level. So I'm not sure what I want to do with that, but there are a lot of nitrogen-fixing bacteria in here. And this is the reason why I wasn't here on Tuesday. My apologies, and thank you. It was a lot of fun. And that's it.